All right, so for 8.3 part 2, I want you to start off by trying to graph this, okay? And the big thing is we already actually know how to graph y equals 2 to the x. This is our exponential one. And remember that this comes with our chart, right? And we have our x's and y's, -1, 0, 1, and then it would be 1 over the base, 1, and then the base, okay? And then if you want to do your inverse, all you do is you take all of these and you just switch your x and y values. Okay, so go ahead and do that for me, please. So if you went through that process, you would have realized that there is no h or k or a. So anytime you're adding h or multiplying by a, adding k, you would still end up with -1, 0, 1, 1/2, 1, and 2. So if you were to graph those, -1, 1/2, 0, 1, 1, 2, you would have this exponential graph here. Remember, domain is always negative to positive infinity, and your range is your asymptote, which is at 0 to infinity. And your asymptote is always y equals k, and in this case, k is 0. So when you graph the inverse, instead of -1, 0, 1 being your x's, those would be your y's. And 1/2, 1, and 2 would be your x's. So we have 1/2, -1, 1, 0, and then 2, 1. So we now have this graph here. So now this time our domain is not all reals. This time our domain starts at 0 and goes to infinity, but our range is the one that's all reals. And our asymptote is no longer y equals k. This one ends up being y or x equals h. Right? We could see that there is an asymptote here. All right, what we actually just did was graphed the logarithm of this. Okay, and that's what we're going to do for the rest of the day. Log functions and exponential functions are inverses of each other, and the graph of the function and its inverse are symmetric with the respect of this line here. So remember, inverses, we have this line, y equals x, and it just gets reflected over it. And you could see that that is the case here. So, like we talked about just above, it is basically what we've done before, but it's just a logarithm. So it's just kind of flipped around. Okay, so we have y equals a times log base b of x minus h plus k. And a, h, and k, all the same rules apply that we have been talking about forever. Okay, you're stretching, you're condensing, you're reflecting. If it's a, h moves left and right, it's always opposite, and k moves up and down. So again, remember, your asymptote now is x equals h, and your domain is the one that changes. Your range is going to be the one that's always negative to positive infinity. Okay, so from here, let's graph this. So again, let's identify our a, h, and k first, and maybe our b as well. So on this one, our base is 3 because it's that little number with the log, right? So when we are using that to help us fill out this chart, remember that it is 1 over the base, base, 1, and then the base. So this would be 1 over 3, 1, then 3. And the right side is now -1, 0, 1. So with our a value, remember that's always the number out in front. If there's nothing there, it's a 1. Our h is always connected to the x, which there is nothing, so that means that's 0. And our k is always what's after it, which there is nothing, so that is also 0. So again, over here, we're always adding h, which in this case, we are adding 0 because h is 0. So we have 1/3, 1, and 3. On the right side, as always, multiply by a, add k. So we are multiplying by 1 and then adding 0, which basically means it's staying the exact same. 1, -1, 0, 1. So again, remember, for log functions, your range is always negative infinity to positive infinity, and your asymptote is always x equals h. So in this case, it's x equals 0. So that would be this vertical line here. If we plot those points, 1/3, -1, 1, 0, and 3, 1. So we have this function here. Again, make sure that it is not crossing the asymptote because it cannot touch the asymptote or cross it. This does mean that our domain is from h to infinity, and the same rules apply here. It's either h to infinity or it's a negative infinity to h, just like with the range for the exponential functions. So we just have a couple more examples that we're going to go through. So we have number 7. First off, let's identify a, h, and k. Our a value is 3 because it's the number out in front. Our h is a positive 2 because it's the opposite of the thing connected to our x. There is no k, so it is 0, and our base is 3. So once again, we are doing 1/3, 1, and then 3 over here because it's 1 over the base, 1 and the base. And on the right is -1, 0, 1. From here, we are going to add 2 over here because it's always plus h. So we get 2 1/3, 3, and 5. On the right side, we are going to multiply by a, add k. So we are multiplying by 3, then adding 0, or just multiplying by 3. That means we get -3, 0, 3. Now, I do not have to graph it to be able to fill in my asymptote and my range. Remember, range for these, for logarithms, is always negative to positive infinity. And our asymptote is always x equals our h value, which is 2. So we can draw that first. And then we can plot those points. 2 1/3, -3, 3, 0, and 5, 3. So this one's definitely flattened out. That was really bad. Let's try that again. So this does mean, because it's to the right, it's going to be from our asymptote to infinity. 2 more examples. So our a value is -1. Our h is inside with the x, and it's a -1 because it's opposite. Our k is on the outside all the way to the right, which is -5, and our base ends up being 1/2. So again, we have 1 over the base, 1, and then the base. When your base is a fraction, remember, all we do is flip it. So this becomes 2, and then 1, and then 1/2. We still have -1, 0, 1 over here. And as always, we are adding h, and then multiplying by a and adding k. On the left, when we add h, we really are just subtracting 1. So 2 minus 1 is 1, 1 minus 1 is 0, and 1/2 minus 1 is -1/2. On the right side, we are multiplying by -1, and then we are adding k, which is really actually subtracting 5. So if we multiply by -1, we get 1. 1 minus 5 is -4. Next one would give me 0, then 0 minus 5 is -5. And then we get -1 minus 5, which is -6. Again, we can go straight to our asymptote because it's x equals h, which is -1. And our range is negative to positive infinity. From here, we can plot our points, and I'm going to draw our asymptote as well. We have our point at 1, -4, 0, -5, and -1/2, -6. Our domain is always going to be h to infinity, so that ends up being -1 to infinity. And actually, while I think back about it, with logs, you're always going to end up going in this direction. It is going to pretty much be consistent where it is h to infinity. Whereas with exponentials, it's not. So I'm still going to think about it with you and really focus on it, but that's pretty much always going to be the case. Last one. So for this one, our a value, there is nothing out in front, which means it's a 1. So we would end up multiplying by 1 over here. Our h value is inside with our parentheses with x, so it is a -2, which means we will subtract 2 on this side. And our k is a -3, which is what's all the way out to the right. Our base is always that little number with the log, which is 4. So if we fill in our chart, 1 over the base would be 1/4, and then 1, and then the base, which is 4. On the right side is -1, 0, 1. So on the left, 1/4 minus 2 would give me -1 and 3/4. 1 minus 2 is -1, and 4 minus 2 is 2. On the right, multiply by 1, subtract 3, and we get -4, then -3, then -2. Again, our asymptote is always x equals h, so x is going to equal -2. And we could plot those points. -1 and 3/4, -4, -1, -3, and 2, -2. Our range, again, is always negative to positive infinity right now. And our domain is always involving our asymptote, so -2 to infinity.